Sometimes space doesn't shout its mysteries. It whispers to them. A faint point of light drifts against the stars, almost invisible, yet its behavior sends ripples through the scientific world. That's what's happening right now with 3I ATLYS, the third known interstellar visitor to enter our solar system. A few weeks ago, something strange appeared in the tracking data. According to several independent observatories, 3I ATLYS wasn't exactly where it was supposed to be. It had diverged from the official NASA JPL prediction by 5.4 arc minutes, roughly 1.1 million kilometers ahead of schedule. Now, 1 million kilometers may sound enormous, but in cosmic navigation, it's a delicate difference, a whisper of change in a sea of emptiness. Still, for astronomers, it was enough to raise eyebrows, because that deviation didn't fit the expected trajectory governed purely by gravity. And that small anomaly led to a provocative question: could an object from another star system have adjusted its course? The report making waves is titled 3I ATLYS Tracking, Active Maneuver Confirmed. In it, a coalition of independent astronomers claim they detected a measurable offset between 3I ATLYS's predicted location and its observed one on October 21st, 2025. They argue that this isn't just a rounding error. According to their calculations, 3I ATLYS appeared to have accelerated actively, as if under some form of propulsion not accounted for in standard gravitational models. The document even lists geometric shapes within the comet's tail, unusual plasma regions, and a 26% drop in brightness relative to models, despite it supposedly losing around 25 kilograms of water per second from sublimation. It concludes with a bold statement: if this deviation persists when 3I ATLYS reappears from solar conjunction on November 3rd, it will confirm the presence of an active trajectory adjustment. In plain words, they're implying that 3I ATLYS may have maneuvered. It's an extraordinary claim, but before we leap to extraordinary conclusions, let's examine what's actually known and what could be causing these numbers to appear so strange. ATLYS is what we call an interstellar object, meaning it doesn't come from our solar system. It was discovered in mid-2025, becoming the third known interstellar visitor after Oumuamua in 2017 and Borisov in 2019. Its trajectory showed immediately that it was moving too fast to be gravitationally bound to the Sun. It was just passing through. Observations from Hubble and James Webb revealed a faint tail and a cloud of gas consistent with typical cometary activity. Its composition, ices, dust, carbon compounds, looked natural, though slightly unusual compared to solar system comets. And that's expected. Every comet born around our Sun shares its chemical fingerprint, influenced by the Sun's radiation and early solar nebula. An interstellar object, on the other hand, carries the chemistry of its home star system. Its own ratios of carbon, oxygen, and nitrogen, possibly formed around a different type of sun entirely. So yes, 3I ATLYS is different, but different doesn't mean artificial. It means foreign. Here's where things get interesting and important. So far, no major scientific body, not NASA, not the European Space Agency ESA, not the Minor Planet Center, not the IAU, has confirmed this alleged deviation. There are no official bulletins, no peer-reviewed papers, no formal orbital corrections noting any 5.4 arc-minute shift. And that matters, because in astronomy, single independent observations don't count as confirmed phenomena. Every claim must be reproduced, ideally by teams using different instruments and different methods. Until that happens, this maneuver is just a hypothesis. A curious one, yes, but still a hypothesis. And as we've seen many times before, early orbital predictions can appear to fail spectacularly, only for later refined models to fit perfectly once more accurate data arrive. Why? Because predicting the path of a newly discovered, fast-moving, faint object across interstellar space is incredibly complex. Even a minuscule uncertainty in its position or speed can expand into millions of kilometers over time. That's just how orbital math works. So, before we assume 3I ATLYS fired its own engines, we have to rule out the far simpler explanation: the orbit was never that precise to begin with. Now let's talk about non-gravitational forces, the very real natural effects that can make a comet seem like it's steering itself. Comets are not just chunks of rock and ice floating passively through space. They're active, constantly changing. As they approach the sun, sunlight warms their surfaces, turning frozen ices directly into vapor, a process called sublimation. The escaping gases don't leave quietly. They shoot out as jets, plumes of gas and dust that can act like miniature thrusters, gently nudging the comet in unpredictable ways. The Rosetta mission to Comet 67, Churyumov-Gerasimenko, witnessed this firsthand. Hundreds of jets erupted from 67 Pesos's surface, altering its spin, rotation, and even its orbit slightly. Those tiny, unbalanced pushes were measurable, and they looked almost like course corrections. ATLYS could easily be experiencing the same phenomenon. Because it's tumbling as it moves, the direction of these natural thrusters constantly changes. Over days or weeks, the small pushes add up, enough to produce a deviation that looks suspiciously deliberate from Earth's perspective to an observer with incomplete data that might look like propulsion. In reality, it's just the messy physics of a comet breathing in sunlight. Now, what about that 26% dimming, the brightness anomaly mentioned in the report? Brightness, or apparent magnitude, in comets isn't fixed. It changes dramatically with distance, angle, and composition. ATLYS has started to fragment, breaking into darker, less reflective pieces. Its overall brightness would drop even if it's still releasing gas at the same rate. That's called a photometric mismatch, and it's common. Alternatively, if its rotation exposes darker regions more often than bright ones, we'd see periodic dimming without any physical change at all. Comet Borisov showed similar fluctuations. So did Oumuamua, which flickered wildly due to its odd cigar-like shape and tumbling motion. So again, fading light doesn't mean fading honesty in physics. It just means the object is complex. Still, speculation thrives in the vacuum of confirmation. The idea that 3I ATLYS could be an artificial probe, a vessel under control, is captivating. It triggers something ancient in us, the hope that we are not alone. People often mention Oumuamua, which also displays unexplained acceleration. Some scientists, including Avi Loeb, suggested it might have been a thin, light sail-like object pushed by sunlight. Loeb himself, however, never declared that conclusion as fact. He framed it as a thought experiment, a way to challenge scientific complacency. That's healthy. Science needs provocative questions. But what matters most is the discipline to separate what's intriguing from what's proven. Right now, 3I ATLYS offers intrigue, not proof. For the moment, 3I ATLYS is hidden behind the sun, invisible to our instruments. But that's about to change. Around November 3rd, it will re-emerge, and a wave of observations is already queued. NASA, ESO, the James Webb Space Telescope, Hubble, the Solar Orbiter, and several ground-based observatories, including ESO, CFHT, and the Subaru Telescope, are all preparing to remeasure its path. These data will show whether the 5.4 arc-minute offset is real or simply an artifact of old measurements. If the deviation persists, it will spark genuine excitement, not because it proves intelligence, but because it reveals new physics or complex natural behavior. And if it vanishes, as most professionals expect, then this entire story becomes a lesson in why we must treat early data with humility. Even if the maneuver turns out to be nothing but natural forces, that's still fascinating. Why? Because interstellar objects are among the rarest things we can study. They're time capsules from other planetary systems. Each one, Oumuamua, Borisov, ATLYS, tells us how matter forms and evolves under alien suns. And if we start noticing consistent patterns, repeated deviations, unusual compositions, then we may be glimpsing an entirely new class of celestial objects. That alone would be revolutionary. There's a human story here too. When people say scientists don't want to believe, they misunderstand the motivation. Science isn't about rejecting wonder. It's about protecting it from illusion. We could easily call every anomaly alien. It's tempting, but the real beauty lies in the process. in waiting, testing, refining, and still daring to ask questions. Every comet, every interstellar traveler, is a mirror reflecting both cosmic processes and human curiosity. Maybe one day we'll truly find a visitor that isn't natural. Maybe one will broadcast a signal or change course in a way physics can't explain. But until that day, we honor discovery by being honest about uncertainty. So now we wait for November 3rd, when 3i ATLYS returns from behind the sun and the instruments awaken again. If the mysterious offset remains, we'll investigate deeper. If it doesn't, the story ends as another reminder that space loves to play tricks on our expectations. Either way, we learn, and maybe that's the real maneuver here, not 3i ATLYS changing its path, but humanity adjusting its understanding. Because whether it's dust, ice, or something far stranger, what 3i ATLYS proves is this: we're finally watching the galaxy, and the galaxy is beginning to notice us back.